All right, ladies and gentlemen, so we're starting in chapter 3 now, and chapter 3 is where it starts getting a little bit more interesting because now we're going to start looking at algebra. So if you look down here, it says algebraic expressions, and that's what we're looking at today. But we have to understand what the parts are to every algebraic expression. So the first thing we're doing here is we're doing page 115, 8 through 13, and in this first thing we just got to identify. So it says identify the terms, coefficients, and constants in the expression. So every expression can have several different things, but these ones, they're just trying to help you identify two different parts. But I'm actually going to show you three different parts, because if you don't understand what the third one is, the one of the other two won't make any sense at all. So I'm going to write this down. I'm going to write 7h plus 3. Okay, this is an algebraic expression. It's not an equation because it doesn't have an equal sign. It's an expression. So it has three things here. It has this number 7, it has this h, and it has this 3. This, as we all know here, is called an operator. Addition, subtraction, multiplication, division. Those are all operator signs, and that tells you what to do. It tells you to add, it tells you to subtract, it tells you to divide, it tells you to multiply. Those are operators, and that's not what we're talking about here. We're talking about these three things, this 7, this h, and this 3. Okay, this h here, and any letter, whether it's an English letter, a Greek letter, any letter, is called a variable. Okay, a variable. And all variable means is any symbol that is not a number that represents something else in a problem or in an equation or in an expression. So in this particular expression, this h represents something other than the letter h. It generally represents another value, number value. Okay? When you have a number or a numeral that's attached to a variable, it has a special name. So this particular number right here is called a coefficient. Coefficient. It's right here. Coefficient. Okay? And a coefficient is a value, a number that has value that's attached to a variable. When they're attached together, that variable has a variable and a coefficient. So this coefficient right here is attached to this variable. When you have an unattached numeral or an unattached number, this is called a constant. Okay, a constant. Okay, a constant is any unattached value. So this 3 is unattached to anything else in this equation. It's all alone over here by itself. So that means it's constant. A coefficient means that there's some other value here acting upon it, but we don't know what that is yet because it's a variable. We haven't solved this problem, so this 7 is part of the total value of this. That's why it's called a coefficient. Co means together with. So together with this variable, it has value. Okay, it's not 7. It is until we find out what it is with the variable, but what it means is that together with this variable, it has another value. This 3 doesn't have anything next to it, so that it has a constant value of 3. So in this problem, the 7 is your coefficient, the 3 is your constant. Okay? Now, we need to find a way to quickly and easily identify our coefficient, our constant, and our variable. So for number 9, we're going to come up with a code, and we're going to write it up here. So I'm going to write COF for coefficient, COS for constant, and V for variable. So this is coefficient, coefficient. This is constant, and this is variable. Okay, and that's just a code for me, so I don't have to write down these big long words every time. This is my set of codes. I can't just write C, C, and F because coefficient and constant, they start with the first 3 letters, so COF and COS work for me. So I'm going to put number 9, and I'm going to write down the expression that they give me, and it's the letter G plus 12 plus 9g. And notice the 9 and the g are right next to each other. So now what I can do is I can write v, this is a variable. I can write, this is a constant because it's unattached, so this would be COS right here. This 9 is attached to this g, so this would be the coefficient. So COF here, and this is a variable here. So that's how I'm going to go through and I'm going to label these on these problems. So here's number 10. Okay, I'm going to write it down, 5c squared plus 7d. Okay, so here is a value attached to a variable. So I'm gonna label my variables really quick. This is a v for variable. This is a v for variable. This is attached to a variable, so this would be a what? This would be a coefficient, so COF. And the 7 is attached to a d, and so this would be a COF as well. Now, I know that there is an exponent here, but we're not asked to label exponents. So the exponent acts upon this value. It's not a separate term. We're only looking for constants, coefficients, and variables, okay? So this is acting upon this. It's not a constant, it's not a coefficient, it's not a variable. It's basically like an actor. Okay? So you're going to continue 11, 12, and 13, and now we're going to move on to 16. So on the next page, on this page number 116, we're going to be asked to do two more things, and I'm going to go through both of them for you. So I'm going to write 11, 12, and 13 so that when we go over this, I'll have a place to put the work. And so now I'm going to start with number 16 here. So this is where 16 is going to begin. And so here's 16. Now the instructions here say write each expression using exponents. Okay, remember how exponents works. Exponent was how many times the base number is multiplied by itself. So in this case, it says b, this is a time symbol, b, this is a time symbol, b. Okay, in algebra, it's common for them to use this dot, this heavy dot, to mean times. So we got b times b times b. Okay, now what that would be, and you don't put an equal sign over here because it's an expression. We're going to work down because that's how we do it algebraically. This would actually be b to the 1, 2, 3rd power. So it would look like this. Okay, 17. I'm going to write down what they've given me on my paper. And it's g, 1, 2, 3, 4, 5 times. So g times g times g times g times g. That's 5 times. So this would be g to the 5th power. And that's all you need to do. These are really simple. So you're going to do this for 18, for 19, for 20, and for 21. Okay, and then we're going to do 25 through 36. So I'm going to put 25 right here. And I'm going to explain how these work. So these say, evaluate the expression when a equals 3, b equals 2, and c equals 12. They're giving you the value for the variable in the problem. Let me show you what that looks like. That looks like this. So I'm going to write down what they give me. This is 6 plus a. 6 plus a. And yes, I know I make a kind of an old-fashioned way, but that's how I have always done it. So 6 plus a. Now, here they've given me the value for these. So I'm just going to write them over here in the margin. I'm going to write a equals 3, b equals 2, and c equals 12. So this is the value that they're giving me. Now, they've given me this problem, 6 plus a. They've given me the value of a. So now I'm going to rewrite the problem. 6 plus 3. 6 plus 3 is 9. 9 is my answer. Number 26 looks like this. B times 5. Okay, b is equal to 2, so I'm going to rewrite this. 2 times 5. 2 times 5 is 10. Easy solutions. These are not difficult. All right, number 27. C minus 1. C equals 12, so I'm going to rewrite this. 12 minus 1 is 11. All right, so you're going to continue, and you're going to do 27, 28 through 36. Okay, remember your symbols here. You got minus, plus, 2a. Let's look at 31. Let's do 28, 29, 30, 31. When you see 2a, when you have a variable directly next to a number and you know what that variable is, this is a multiplication problem. So multiplication is one of those funny things in math. There's lots of different ways to show it. If the two numbers are squashed together, that's multiplication. If you have quotations like this, that's multiplication. If you have 2 times a, that's multiplication. If you have 2 times a, that's multiplication. All of those are multiplication. Don't ask me why. For whatever reason, mathematicians just decided that's the way they wanted to do it. So this says 2a. So this is really 2 times a. And since we know that 3 equals a, I'm just going to rewrite it like this. 2 times 3. Okay? So 2a is 2 times 3. 2 times 3 is 6. Okay? Yeah, I know that's weird, but that's the way that it works sometimes. Like I said, mathematicians were weird when they came up with all the different symbols for indicating multiplication. I'm going to look at one more here. 33, 34. I gotta turn my paper over here. And I'm gonna have you look at 35 really quick. 35. So 35 looks like this: C over A. Okay, so I'm gonna write down the values. So C is 12. 12 over, well, A is 3. Okay, remember this is a fraction, and remember every fraction is a division problem. So we're just gonna divide. How many times does 3 go into 12? It goes in 4 times. So 3 goes into 12 4 times. So 3 divided by 12 is 4. That's my answer. It's a division problem. Remember, every fraction is a division problem. Okay? And you'll do the rest. You'll do all the ones that we haven't done yet. Ready, set, go.